Hey everyone, today we are going to start with a much awaited module, Introduction to Machine Learning. In this module, we are going to essentially learn that machine learning in itself is not something which runs in isolation to the business problems. We are trying to solve business problems. We will learn about how to convert a business problem to a machine learning problem, or rather how to connect both the things. In order to learn that, we will see what all kind of machine learning problems there exist, supervised learning, unsupervised learning, and then subdivision of those. Then we will learn about what drives the learning process, how do we build a predictive model. We'll learn about technique which runs almost at the back end of any machine learning algorithm that we are going to learn, the gradient descent. We will close this module with hands-on example of using gradient descent to learn a very simple model right there in Python. Okay, let's begin. We will see how to convert a business problem to a machine learning problem first, or how do we connect or how do we go from having a business problem to solving a data problem using machine learning techniques. Let us see. In order to do that, first we need to realize what a machine learning problem look like. What all kind of machine learning problems exist. So there are two famous labels that you must have also heard, that is supervised learning and unsupervised learning. Easier or layman's explanation for that will be supervised learning problems are prediction problems, where you're trying to predict a certain outcome. For example, you want to predict how many runs India is going to score in a certain match. So, score India team. As opposed to you want to predict whether India is going to win a certain match or not. Both of these are prediction problem. Of course, there are some underlying factors which we are going to use, such as what all players are there in the team, where are we playing this, is this a fast pitch or a spinning pitch, who are we playing against, and so on. There are a lot of factors which affect these outcomes. What is fundamentally different about these outcomes? This score is a number. It's a continuous value. It could be anything starting from maybe 10 runs up till 350 or 400 runs. Okay, so this could be any value on a scale. This, however, is a class. Outcome is either yes or no, or maybe a draw. Okay, these values are not a number on a continuous scale. Generally, any business problem or prediction problem will come down to this, where you either have a continuous numeric outcome like this or a classification outcome like this. These kind of problems under supervised learning are called regression problem, as you can see on the slide. These kind of problems are called classification problem. Okay, so more or less at a very broad level, we understand what are these supervised learning problems. We'll take up some examples as well. So what is this unsupervised learning? Unsupervised learning is where you are not trying to predict something, but you are trying to understand underlying patterns in the data. What do we mean by underlying patterns? Few examples could be that you want to identify among a class of, let's say, 100 school going children who are going to be good at cricket. What chunk is going to be good at, say, football? What children rather prefer playing video games? What children will rather prefer indoor games? And so on. So there are different group of children in that class with different preferences or different capabilities. There is nothing to predict here. We are just trying to find out group of children which happen to have similar interest within the group and different from the other groups. That could be one. Another could be where you are doing a survey which maybe has hundreds of questions. Okay, and these questions relate to, maybe you are just trying to scope out a market for a certain product that your company is going to launch, and these 100 questions are like, what are the brands that you subscribe to, what, let's say it was clothing line that you're going to launch. So you're asking questions like, what kind of fabric do you prefer, what kind of designs that you go for, what colors do you like, what price range you're comfortable with, and so on. Eventually, hundreds of these questions may be representing 8 or 10 underlying preferences for people. Essentially, starting from these 100 survey questions, you are trying to judge 10 latent factors, 10 factors which drive or manifest themselves as answers of these 100 questions. That is called a problem of dimensionality reduction. Most of our problems, or most of the algorithms that we are going to learn, are going to be of type supervised learning. Okay, because most of the business problems that you are going to be working as data analyst are going to deal with predicting outcome of certain business processes before you observe them for real. Since we are going to focus so much on supervised learning, or rather, since we have to focus on supervised learning so much, let's summarize at a very broad level what are the components of a supervised learning problem. We essentially have outcome. We essentially have an outcome which can be either continuous numeric variable, or which can either be continuous numeric value on a scale, or it can be classes. These outcomes are being driven by some underlying factors which we are going to call predictors, and we'll be calling the outcomes as target or response. Our goal is to use these predictors to feed in some kind of box which contains our predictive model and outcome or predictions for the targets. Simply put, this is what we are going to do. But of course, there is a lot of work which goes on in the process, but at a very broad level, this is what's going to be. Okay. Now, before we start doing this, before we start building predictive models which make use of predictors to make predictions for targets, we need to first bring down a business problem to this level where we identify, okay, what is the target, what is the outcome expressed in data terms for this problem, what are the predictors expressed in data terms for this problem. Here are two examples for that. So first problem says, or real business problem talks about that a bank is making too many losses because of defaulters on retail loans. So if you think about this business problem from the common sense perspective, is we can bring down the impact of defaulters by identifying the defaulters before we give them a loan. Identifying the defaulters. So if by looking at the loan application, we can say somebody is going to repay their loans or not going to repay their loans, that will solve the problem, right? So this is our target which we want to predict somebody is going to default on their loan or not. And how we are going to do that? What are the factors which are driving somebody to default or not is their characteristics, and their characteristics are contained in this loan application. So this could be what amount of loan they are applying for, what is their age, what is their credit history, if there are some family information, how many children do they have, what kind of job they do, what is their take home family income, and so on. These are going to be my predictors. Okay. Here, if you notice, the target or the outcome is not on a scale. Somebody defaults on their loan or they don't. So there are two possible outcomes. This is a classification problem. Okay. Now let's talk about one more example that you see on the slide. That is, an e-commerce company wants to know how it should plan for the budget on cloud server. So these days, many of the businesses host their apps on cloud server, elastic servers, as in when the load goes up, they make use of more servers. When the load is down, they make use of lesser number of machines, and this greatly optimizes the cost that they have to spend on the infrastructure. Now, of course, this will work even better if a company can forecast how much money would they need to put in, how many machines they might need to involve in future, and they can accordingly plan their budget. What we want to predict: how many machines will we need to deploy in future, which essentially boils down to how many people, traffic to my app or website, traffic to my app or website, number of people using my app or traffic or app or website at a time. So this is what I want to predict. Underlying factors, as I've listed, it could be what season it is, what time of the day. Maybe if I want to make predictions at a more granular level, at every minute of the day. So what time of the day it is, how many visitors came on this during this period last year or last month, So there can be a lot of underlying factors which will help us in predicting what could be the traffic on my app or website at any given time, or another way to put that will be load on my server. You can see here this number of people visiting your app or website at a time. It's going to be a number on a scale. It could be 2 people at a time, it could be 1,000,000 people at a time. So it could be any of these numbers at a scale. So this becomes a regression problem. Okay, keep that in mind. So this is a regression problem, and we're learning about both kind of techniques under supervised learning, classification and regression both. Now you must be thinking that this discussion on examples was primarily on supervised learning. What happens to unsupervised learning? It's not that the course is not going to focus on unsupervised learning at all. Of course, supervised learning, we will be dedicating a good amount of time for unsupervised learning also. A little discussion on that. What kind of problems are we going to solve using that? As we have already discussed, unsupervised learning is where there is nothing to predict. We are just trying to learn underlying patterns in the data. I gave you a couple of examples there. And majority of usage comes in when we are trying to find out customer groups, so that we can design our products in a very targeted fashion. We can design marketing campaigns in a targeted fashion. Unsupervised learning will also concern itself with the anomaly detection, where there are tons of data points and you want to isolate the ones which are unlike the rest of the population. They are very different from the other ones. We can use it for dimensionality reduction. We'll be using it for latent factors. The example that I gave you, that I want to find out 10 latent factors which are driving maybe answers to hundreds of questions. So we will be dedicating a good amount of time on learning techniques to do these things as well, which come under unsupervised learning domain. The next, we are going to learn about what drives all these algorithms. Okay, intuitively it makes sense what we are trying to build here, but how do we build there? How do we mathematically express this intuition is something that we are going to learn in the next video, which will be about cost functions.